All right, good afternoon, good morning. This is Math 2. It's December 2020 this year. Who knows in years future or past what day this will be. So we've already done a little bit of a review on this function group, and I will post those answers on Canvas, so look for these answers. You had the Edpuzzle yesterday, and then you have the solutions posted today. So make sure you check that. And we're going to kind of piggyback with the piecewise today. Slope-intercept form, point-slope form, and yesterday you did a lot of the function notation, and we're going to talk more about piecewise. All right, so there are two ways in which we write the equation of a line. Slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept. So the y-intercept is where x is 0, and then the slope is your rise over your run. Change in y over change in x. You can just remember this a couple different ways, whatever that may be, that you can remember your slope. Point slope then is kind of an easier way to write a line, because then all you need is one point, the slope, and then you can write it. And then you can convert it back into y equals mx plus b. So we did a few of those yesterday. I'm going a little fast so that you can pause the video. I'm trying to keep it to 15 to 20 minutes. So feel free to pause. Given a line with a slope of 1/2, okay, so m is 1/2, and passing through the point, so the point x1, y1 is 4, 3. Write the equation of the line in point slope and slope-intercept form. So point slope, I take y equals m, x minus that point, okay, plus y1, 3. Now, sometimes I see this as y minus y equals m times x minus x. Personally, I think that's a little bit easier. Those are your x1, y1 points. This is just with y kicked over, okay? So same thing, you're going to plug and chug. So y minus y equals the slope times x minus the x value. So if that's a little easier, this is just with 3 kicked over already. So if you're going to distribute your 1/2 x minus 2 plus 3, I'm sorry, I'm bleeding into the next paragraph, plus 1. So just be careful with your distributing, and then when you add 3, negative 2 plus 3 is plus 1. So this is point slope form, okay, and I didn't put the slope here, so there you go. And this is slope-intercept form. Okay, write the equation of the line on the graph in point slope and slope-intercept form. So the 2 points in question are 0, 3, and 2, 0. Those are called the intercepts. So if you want to look at the slope, it's negative 3/2, rise over run. So slope-intercept is actually, you've got the slope and the intercept, so you don't even need point slope just yet. But sometimes people like the routine, so that's fine too. All right, so y minus, I'm going to choose this point, 0 equals negative 3, oh my goodness, I should slow down, x minus 2. So that's point slope, and then if you were to convert it, let's say you didn't write it first, when you distribute that, kind of tricky, don't let fractions scare you. Negative times negative is a positive, the 2's will cancel, and then you'll have 3. So that's slope-intercept. All right, write the equation of the line that passes through 2, 5 and 2, negative 3. Describe the line. So let's just sketch it. 2, 5 and 2, negative 3. So this is a vertical line, so we're kind of describing it. Vertical line, slope is undefined. U-N-D-I-F-N-E-D. Okay, so the vertical line is going to be x equals 2. So you can't use traditional y equals mx plus b because of that slope. So let's say you found the slope to be 5 and 2 minus 2. So you'd be like, oh, 8 over 0 is undefined. So then you might be stuck. So that's why sketching it kind of helps you see that when there's special cases. So this is the other special case. So here we have 2, 5 again, but then we have negative 4, 5, negative 4, 5. Now when you sketch, you don't have to make all these tick marks. So when I watch kids sketch and they're making all these tick marks, you don't have to do that. As long as you've got your points in there, you're good. So you can be efficient. All right, now this is a horizontal line. Horizontal line. Take this because I'm gripping for it like dear life. Okay, now horizontal line, the slope is 0. And this would be y equals 5. So y is the constant. So it's always the constant that you know, like here x is 2, so that's why the line is x equals 2. A lot of people think because this is the x-axis and this is the y-axis that it should go like the other way. Like, hey, it's a vertical line. Why isn't it, y equals? No, it's because the x value is constant. Whereas here, the y value is constant. So it's y equals 5. So those are your two special cases. Hopefully a little bit of Math 1 junior high is coming back to you. Okay, part 1. Now we're going to kind of do this graphical representation. So if you were to create a story about what happens here, this is, a lot of people do like, let's say it's the distance from somewhere. So I traveled to my friend's house, I stayed there for a while, then I rode my bike somewhere else. But it's tricky because you have to have defining variables here. Let's say you're talking about boiling water, okay? So temperature over time. So, I heated up the water, I turned it off for a while, it stayed this constant temperature, then I came back to it and reboiled it, and then I let it cool. So if this was temperature and this was time, those would be a couple of different stories. So the other day I asked you to create a story, and I could tell a lot of you were like, I drove here, I stayed, I drove. So you really have to have defining X and Y axes. So we'll talk about this. This is like the real life story. There's a couple of fun videos I have for this that we can use. So we're going to watch a couple of real life videos. We'll watch, look at that, real life videos in class tomorrow. And I'll also check your Desmos too. All right. Okay, but if you were to write a function to match each part of your story or each section, how many would you write? So this is the key ingredient that you need: part 1, part 2, part 3, part 4. So there would be 4 parts, and they each have a slope, all right, and an intercept and all the rest. So if you were to write it in pieces, that's what would happen. Now on Desmos, that's another thing I'm going to have you we'll check out tomorrow. There's beautiful piecewise graphs, B-E-A-U-T-I-F-U-L, P-I-E-C-E-W-I-E, which I'll also show you tomorrow. And they incorporate like parabolas and exponents, and when you put it all together and you have what's called an overlay, you can get a beautiful picture. So I may assign one for extra credit over break, but it's going to be, it's not going to be that involved. We didn't do our Pilgrim hat this year, but once you get the hang of it after this chapter, you should be pretty good. All right, but mathematically, we have to write each of these parts. So we've been working again with linear, okay? So let's talk about what each of these points are. So we've got 0, 0 to 5, 5. So we would have to write the line to part 1. Well, we know that the slope is 1, up 1, rise over run, and the intercept is 0. So this would be y equals 1x plus 0. Okay, so this takes care of it, so y equals x, but I only want, and this is the domain, remember domain is input, I only want from 0 until I get to 5. So for 0 less than or equal to x less than 5. Now I'm not including 5 because it picks up again right here. Okay, now this line, we just reviewed a horizontal line. That's the line y equals 5. Okay, it's a horizontal line. The 5 is constant. So it's only 5 from 5 until I get to 10. So this is, remember, you read your domain here. These are our domain pieces. Now, if I don't include it here, I have to include it here. I don't include the 10, so the 10 is going to pick up here until I get to 15. Sometimes if my students, if they can't write the function, they'll at least write the domain. Okay, so this domain is 15, and then it ends, I'm assuming 20, 16, 17, 18, 19, 20. So you can pick up, so that's what I want you to mainly understand, that the domain is the input. You can do that. You can all read along the x-axis to see where those are. All right, this subfunction, now this line, so it's the line between, now we just spent 2 days writing lines, so it's the line from 10.5 to 15.15. So let's find the slope. 15 minus 5 over 15 minus 10 is 10 over 5, which is 2. And then let's go from a point slope to well, I'm going to choose this point. Y minus 5 equals 2 times x minus 10. So y equals, you don't have to distribute this. I've seen books do both ways. I've seen it like this, where you don't have to distribute, and I've also seen it with it distributed. So minus 20 plus 5, so y equals 2x minus 15. Okay. So as a class, let's commit to making it in slope-intercept form. Because if you don't like point slope and you put it in y equals mx plus b, then that's probably just easier for you to keep with writing the equation of the line the same way you've been doing your whole life. All right, so on that note, let's write this last one. So if you need to pause that, otherwise I'm going to scoot. All right, so now this last one, part 4, is a line. I'll just write it in different colors so you can see it, since I'm writing all over the page here. So I'm writing this last line, which is from 15:15 to, this is 20:10. Okay. So I'm just writing it in green so you could see it. So that's going to be this last one. So the slope is 10 minus 15 over 20 minus 15. So the slope is negative 5 over 5, which is negative 1. And if you can see that because it's falling by 1, that's great. So then if I go from point slope, I'm going to choose this point. I usually circle the point that I'm choosing. Y minus 15 equals negative 1, x minus 15. So y equals negative x. So I'm going to do this at once so that I can squish it. So negative 1 times negative 15 is plus 15. And then I'm going to add 15. So I'm going to get 30. So here, look what I'm going to do anyways. So that was when I distributed the negative 1, and then that's me adding 15. Sorry, So I get negative x plus 30. I'll stick with green. So you just wrote your first piecewise graph. Okay? Now, I kind of vacillate between the two. Every graph that's in pieces is called a piecewise graph. Whether or not it's a function depends if it's continuous. So we'll talk a little bit more about that. Most of ours are going to be continuous for now, but you will get breaks in the action, and then it's called discontinuous, and then it's not a function. Okay. The function you created is called a piecewise defined function. A piecewise defined function, I'm just reading this to you, is a function defined by more than one subfunction or piece of the function. So these are each pieces of the function above. But the function above, this is one piecewise function. These are the subfunctions that make that up. Any absolute value graph is a piecewise. With each section only existing in a certain interval of the function's domain. All right. So we haven't, I don't know if you did absolute value last year, but like, let's say I have this absolute value graph. It's technically a piecewise. So from negative infinity, let's say this is 5, until 5, it's a certain thing. And then from 5 to infinity, it's another line. All right. Okay. And the last page, connecting function notation to a piecewise defined function. So use the story you created to explain the meaning. So the f of 12. So we're still using this graph, but now we're just going to look at the graph. So when I look at 12, remember this is 10, 11, 12. The output, when you follow it up, is right here. Oopsies, right there. But you could also go in here and find it in the algebraic domain. So the f of 12 would fit here. 2 times 12 is 24, minus 15 is 9. So this output is 9. I just kind of made a terrible dot. So sometimes a ruler will help you. I mean, a ruler will generally help you, but that's where you can see that 12, 9. So you can see it on the graph, and you can see it when you plug it in, but you have to plug it into the correct subfunction. So you, in this case, 2 times 12 minus 15. But I would reuse the graph. So that means it's 12, 9. So the f of 12 is 9. So there's a couple ways you could see it. F of 12 is 9, or as an ordered pair, 12, comma 9. Which subfunction would you use to algebraically find it? Part 3, which was 2x minus 15. Because that's where the domain fell. The domain fell between 10 and 15. Oh, I should turn off my phone, I'm sorry. Okay, find the following, f of 7. Again, I can make a graph, look at the graph and see that it's 5. Or I can see that 7 falls in here and that x is 5. Or y, I'm sorry, y. If the output is 3, find what x is. So the hint is, what is x when the output is 3? Remember, that's what that is. The output is 3. So when it's inside the parentheses, it's input. That's the input, x. But when it's the outside, this whole thing would be the output. Okay, so when the output is 3, 1, 2, 3, it's in the first subfunction. Okay? So it's, it's going to be really confusing. It's 3, because look at, this is the point 3, 3. No, that won't always be the case, but for this one it is. When the output is 13, so that's what I want you to start to say to yourself. Self, when the output is 13, what is the input? Okay, So I'll go to my graph and see that at 13, it's in subfunction 3. Okay, so 2x minus 15. Or you can use your ruler to dial down and get 14. And you could do both. So hopefully I can see when my output is 13, I'm going to use 2x minus 15, add 15, get 28, divide by 2 to get 14. Okay, and now this is input. So when the input is 15, look at that was this endpoint. Okay. Oh, this was, this one should be right there. Because technically it doesn't matter because it's going to be the same point, but this one should be, it's got to be closed on one of these puppies, so fix that. That's why I work in pencil, right, boys and girls? Okay, so I'm going to plug in 15 right here. So I'm going to plug it into subfunction 4, which is minus x plus 30. So minus 15 plus 30 is 15. I know this is probably confusing because it's the same. This was meant to be like an easy start. So with a slope of 1 and negative 1, they're going to have the same input-output. So, but no, that's not generally not the case. Well, it wasn't here either because that slope wasn't 1. All right, that is it for notes. Your homework is 4.1 ready. Okay, you can do that. Find each output with each input. The set, you're going to try to read this and kind of interpret the context. Okay, you're going to write a piecewise. And then the go, turn the page, turn the page. Oh, my computer literally just went off. Bless my heart. Okay, so this is still recording, but it might have blacked out. And then another piecewise. And lost my pen. And write the equation of the line. Okay, so 4.1, ready, set, go. I do have a review night tonight. And have a wonderful, wonderful day. All right, so ready, set, go. 4.1 is homework. Review night tonight, 6 to 8 p.m. Bye.